In this video, we'll be looking at graphing linear functions. Now, there's more than one way to graph a linear function, but the two most basic ways to graph a linear function are using intercepts or just points. So let's look at using intercepts first, and then we'll move on to points. And so in order to use intercepts, first we have to know what the x and y intercepts are. Well, the x-intercept is f of x equals 0. And the y-intercept is when x equals 0. So if we apply those ideas to this equation right here, the x-intercept would be where we let f of x, this whole piece, be 0. And so what we're saying is that 0 is equal to negative 2x plus 6. Now, in order to get x by itself, we have to subtract 6 from both sides. And so we get negative 6 equals negative 2x. And so x equals 3. And so the ordered pair here is 3, 0. So now I'm going to take this point and I'm going to come to my graph of the intercept. And I'm going to go 3 over and 0 up, 3, 0. Now, let's find the y-intercept. So the y-intercept is just where the x itself is 0. So what that really means is f of 0 is equal to negative 2 times 0 plus 6. Okay, well that's f of 0 equal to 6. Right? 2 times 0 is 0, so we're just left with 6. So that means the ordered pair here is 6, 0. So let's go to our graph. I'm sorry, I wrote that backwards. Let's not write it that way. Let's write it correctly. The x value comes first. And so we go 0 and then up 6. 1, 2, 3, 4, 5, 6. There's our point. Now, when graphing, all you need is 2 points. Graphing a linear function. So we're going to just connect our 2 points, hopefully a little better than me. And so what we find is that there's our line. Now, how can we get that exact same line if we just use points? Well, sometimes points are easier than finding the x and y intercept if we just pick easy points. For example, I like to choose numbers like x equal to 0. Or x equal to 1, or x equal to 2. Those are pretty easy points. We can just plug x in and get a value out. So when we plug 0 into this, well, we already did that. So I'm not going to do that one again. But if we plug 1 in, what do we get? If we plug 1 into this equation here, actually I want to use red. So if we plug 1 in, we get f of 1 is equal to negative 2 times 1 plus 6. Well, that's negative 2 plus 6. What's negative 2 plus 6? F of 1. So negative 2 plus 6 is 4. So our ordered pair here is just 1, 4. For 2, we do the same thing. F of 2 is equal to negative 2 times 2 plus 6. Well, what's negative 2 times 2? That's negative 4. Negative 4 plus 6 is 2. So f of 2 is 2, which the corresponding ordered pair would be 2, 2. Okay, well, let's go and put these 3 points on our graph and see what happens. 1, 2, 3, 4, 5, 6, 0, 6, 1, 4, so 1, 1, 2, 3, 4. And then 2, 2, 2, 2. And if we kept going, we did one more point. Let's say x equal 3. Well, hey, we already know if x is 3, we get 0 back. So that's 3, 0. And so 3, 0 would be here, and we get a line. Now, because I'm inaccurately drawing. The scale is not right. I'm not able to connect the dots, mostly because I'm not very good at drawing. But forgive my drawing. The lines are supposed to be the same. And you can kind of see that their slope is similar. But they should be the exact same slope. And we know that because all of these values are the same. 3, 0, 0, 6, we got the same thing. So there's two ways to do that. Now, what if we don't have any of this information? What if we don't have points, we don't have the intercept, we don't know what they are, we don't have a line. All we have is the graph. Well, if we have the graph of a line, only thing we know so far is that a line is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, well that's useful, right? Because we know the intercept. We have the same one, the intercept is 0, 6. So if the y-intercept is just the number 6, and so we're going to go ahead and say, in this case, our b equals 6. Okay, and just for space, I'm going to erase this one. We still have the same graph over there. Okay, but before we can find m, we have to define what m is. And we know that m is equal to rise over run. But what does rise over run really mean? Well, it means that there is a change in a change in y, over change in x. Well, how does that correspond with our graph? How do we know the change in y? How do we know the change in x? Well, that is given by y2 minus y1 over x2 minus x1. And x2 and y2 come from one ordered pair, and x1 and y1 come from one ordered pair. So we need to find two ordered pairs on our line. Well, let's pick any two ordered pairs on our line. Let's make it easy on ourselves. We know that that is 0, 6. That's one ordered pair. And we also know that that is 3, 0. So that's our second ordered pair. Now, let's label these so we can get something similar. So let's label this x1, y1, and label this one y2. And now we just plug in the values into our little equation. So when we plug these values into our equation, we would have y2, which is 0, minus y1, well that's 6, over x2. Notice x2 and y2 come from the same ordered pair, and they're also first, minus x1. Well, x1 is 0. So we just get negative 6 over 3, which is equal to negative 2. Okay, well that's really nice, because now we know our m. So we know b and we know m, so we can write down our equation. So our equation now is y equals negative 2x plus 6. Does that look familiar? It should, because that's the equation that we started with.